video is part of a series of videos that illustrate how to use the new Revit data exchange ability in direct design. And we're calling this video number 2A, and it's basically a repeat of video 2, but using a different structure so that we can illustrate how to use some of the additional commands for bringing in models from Revit to direct design. So if you've already seen video 2, you can either continue on to video 3, which is the next one chronologically in the sequence, or you can watch 2A here, this video, just to get another pass through the number 2 sequence and kind of cement your understanding of how the various commands work. So let's have a look at the Revit model that we're going to use here for this example. This is a plan view. You can see these light greenish walls are all the walls in the model, and specifically this darker perimeter here represents the structural masonry walls. We've got another illustration of this just to make sure we can really have it in mind here as we work through this. So this purple perimeter here, these walls are masonry. These are the ones that we want to bring in with our import process. So let's jump into direct design now. And you can see we're already in the import environment. So we've already gone through all the step 1 activities. We've exported from Revit, and we've got things into direct design in this import environment. Now the first thing we always want to do is go to the Wall Types tab and filter out walls that we can easily recognize by type. So, okay, we've got some CMU walls here, some concrete walls. Let's see if we just select the exterior CMU walls and jump back. Okay, that took out some walls that we want. So those weren't the right types. I'm going to try a couple other categories here. Okay, now we've gotten all of our structural walls are there. There are some other ones that are also there that we're going to have to filter out differently. And so now we will proceed with that. But by doing the exclusion on wall types, we were able to filter out some of the walls that we don't want. Now what's the biggest challenge you can see right up front? We have got diagonal walls here. The walls we want are rotated essentially, and they're not going to come into direct design this way. They're going to be considered diagonal. And if I go through this invalid walls list, you can see that most of these walls here have diagonal as the reason for not coming in. So we need to use the rotate command. It's this button up at the top here, and essentially what this does is it will rotate all walls through an angle such that the selected wall becomes horizontal in the view. So just have to pick a wall that we want to be horizontal, like that one. We'll click the button, and it's giving us an "Are you sure?" message. We'll say yes, and now it's rotated. So now these walls that we want are no longer diagonal. Now we can do a little cleanup. You see there are some walls that are failing because they're diagonal. That's the remaining portions of walls from the section of the building that's not orthogonal to the section we want. So I can select all those diagonal walls here and go click the remove button here. And that just helps us to clean things up a little bit, see the walls we want and not the ones that we don't want. So what's the next obstacle? All these walls are in red. They won't import. And we're seeing a lot of indications here that the problem is they don't run full height. That means that they don't connect between the stories. And the culprit here is that the stories aren't defined correctly. And we look over here in the bottom right display, we can see that it has brought in many levels from Revit and tried to define stories between them. These aren't the correct stories in this case. It's just a one-story building. And so what we'd like to do is define our one story by wall height. That's usually the easiest way. So I'm going to sort this list by height and start flipping through these taller walls. And let's say that we know that this particular wall here has the correct height for the story. Okay, it's 21 feet 9 inches. That would be something we can verify by looking at the Revit model. And now we're going to come over here and say, please define the story height according to the selected wall. So I click that button, And you can see some things have changed. Some of these walls have turned green, which is good. It means that we're getting closer to being compliant. We've got a problem though. It's identifying structural building sections here between some of these interior partition type walls. And we don't want that. Having some of these walls left in the model here can be okay, but only if they're in red, where they're going to get filtered out anyway. When they start to define sections in a way that we don't want, then they're causing trouble. So I'm going to select this one and just remove it. Okay. And that got rid of the two sections we didn't want, and now we've got one here that we do want, so that's good. This is one piece of one building section, and the next one we want will be we'll rely on this wall here, and you can see that this is two walls. Okay, so I've got this upper wall is, jump over, this is 609,522. The bottom one is 609,040. I'm going to go ahead and select both of those. 522. Now the problem here is that we need, direct design only works in terms of rectangular sections. We can't have perimeters that are more complex polygons with reentrant corners and things like this would be. So what we need to do is combine these two walls into one wall and then just leave an opening here to represent that gap. The import environment can do that automatically. In fact, when I select these two walls, you can see it puts a little dotted line there, and what that's basically saying is, hey, if you choose the merge command right now, these two walls can be joined into one wall, and it will just insert an opening there so that this gap is still represented. So if I click this button, we get a warning to make sure that the user understands the implications of doing this engineering wise. Okay, and for this video we won't dig into that, but that's something that's very important. We'll go ahead and click OK, and now these two walls have been joined into one. The wall is still red, and that's because it doesn't have the correct height right now. That wall's here at the top of the list, and the wall ID is one of the original wall IDs with a negative sign in front of it, so it can be identified that way. And if we just come up here and click the third button in the row here, which will take the selected wall and adjust its height to match the nearest story height. And now we have eliminated the problem with spanning between stories, and we have a second legitimate building section. Now the last piece we need is this little part over here. And if I choose one of the walls there, what's the problem? It says it doesn't run full height, which again means it's not correctly spanning between the stories. So in this case, this wall is actually a little bit taller than the story height, and we can represent that as parapet height. But in terms of the regular unsupported height of the wall, we'll need to make this conform to story height. We can again do that by clicking this third button here. And for this wall, the reason has flipped to where it is now not part of a rectangular perimeter. Okay, so we'll let that sit a little bit, and we'll move on to the next portion of wall in this little square here. And I can look and see that this is 609,354, and that has the same problem. The wall's a little bit too tall. We want to make it conform to the story height, so we'll use this third button here again. Okay, so these two are both the right height. They're just ready to be part of a rectangular perimeter, so we just need to get this bottom section in line. And if I look at the bottom section, that is actually in the Revit model as two pieces, 609,090 and 1123313. So I can come select those. There's one piece. Here's the second piece. And here we once again will have to use the join command. to join those into one wall for purposes of the direct design model. Okay, so that is now joined. Now the last problem is that we once again need to make the wall height conform to the story height. So we'll use this third button again, and now all four walls around the perimeter of this third little section are the correct height. They tie into the story height, and we now have 3 legitimate building sections that can be imported. So by using all these commands up here, we were able to take the structural masonry portion of this building and get it compliant for direct design. We could now click the import button, move on. It'll bring in all those walls and all the openings within them. And that next step is the subject of video 3.